Ever wondered how to host a WebAssembly application with top-tier performance and scalability but without breaking the bank? In this tutorial, we'll reveal a great solution that provides effectively infinite scalability and stellar performance for under $20 a month. Chances are, if you've landed here, you've got a fair idea of what WebAssembly is. But who doesn't love a very quick refresher, right? Simply put, it's a binary format usable across web clients and server applications. This means you can have more than just JavaScript in your web application arsenal, since languages like Rust, C, C++, and Go can compile to WebAssembly. This virtual walkthrough will focus on the client side of things. To make our journey memorable, let's quickly plot our course first, and then let's switch gears to hands-on mode as we build things brick by brick. The plot's relatively simple. We've got a WebAssembly-infused web application front-end, compiled from languages like Rust. To efficiently serve that client-side WebAssembly, we'll need a few layers of cloud services. The star of the show will be an object storage system like Cloud Storage. If you've pledged allegiance to AWS, this will instead be your loyal S3 service. Though we won't traverse each cloud variant in our trek, the demonstrated Google Cloud path should be relatively portable to other clouds. Next layer, load balancing. Our knight in shining armor for HTTPS termination and global networking performance. AWS fans, this will be your trusted elastic load balancing. And to top this off with a cherry, we'll introduce our final companion, a CDN, such as Cloud CDN or CloudFront. We'll touch on some important configuration concepts which maximize performance for WebAssembly workloads specifically. Your CDN will be serving content almost at your user's doorstep. For a sneak peek, check out the dots on Google Cloud's interactive map. Each dot, each edge location plays a part in serving your application all over the globe, optimizing performance and making your website a global phenomenon. You'll tap into the mighty infrastructure and widespread global network that powers giants like YouTube and Gmail. For the sake of those following along from scratch, we'll quickly build a custom web application with WebAssembly. If you already have an application ready, feel free to skip ahead using the video chapters. Our trusty steed for the application construction will be the Cloud Shell Editor. Having a Google Cloud account is all you need for this option. No downloads, licensing, or setup required. Next comes choosing our programming language. While there are other WebAssembly compatible languages, let's roll with Rust, installing it and moving along. We'll use the Wasampack template system to kickstart our project, aptly named Demonstration. So, in the intriguing process thus far, we've constructed an NPM-ready package teaming with our WebAssembly, JavaScript glue code, and TypeScript types. Diving into the JavaScript, you'll note that it essentially just imports our WebAssembly. Instead of fashioning an elaborate NPM app around this, we've resolved to keep it super simple. We'll kick things off with a no-frills HTML file, one that imports our demonstration.js and fires up our greet function. This is ultimately a placeholder, as we'll need a bit more sophistication in our initialization, but this will keep us moving along for now. Peeking into our source code, specifically in this lib file, you may stumble over this greet function, a WebAssembly function. This, ladies and gentlemen, is compiled Rust code that gives us a pop-up in the browser. What's next, you ask? Let's dive right into our deployment. There's some key points that come into play for WebAssembly, especially so when we've got a deployment of this nature. We'll kickstart things with the cloud storage bucket. In our shiny new project, let's voyage to cloud storage and create a bucket. For region selection, a multi-region configuration is often best, ensuring your application is spread far and wide. As hinted earlier, we'll be using the Google Cloud Edge, fortified with the CDN or Content Delivery Network, to turbocharge the performance and availability of our application. We'll need to deselect the Enforce Public Access Prevention on this bucket because we want this bucket to be out there in the open for our public website hosting. For now, let's hop into permissions and make that happen. We'll gift all users a Storage Legacy Object Reader role, enabling anyone to access the contents of this bucket. This is a prerequisite for hosting a bucket-based public website. So, now's the time. Let's bring our files into that bucket. Of course, we want our HTML file, but without our JavaScript and WebAssembly, we'd be incomplete. We'll leave our TypeScript types alone, since that additional complexity doesn't add much value to the demonstration. Back in our bucket, a swift refresh will reveal all our files. If we venture to our index.html, we get a snapshot of what's ticking and what's not. Gazing into the networking tab, we'll find our index loading our JavaScript, but with a gnarly corrupted content error for the WebAssembly. The console is flapping about a disallowed MIME type, but this is a bit of a red herring. Retracing our steps back to the console, instead of just any old WASM pack build, we'll use the target web to uncorrupt our WebAssembly code. This gets the code working smoothly in browser environments. Let's transport the index, JavaScript files, and WebAssembly into our directory. For the next test, a quick check of the developer tools will reveal that the WASM is undefined on line 23. But this is definitely progress towards our goal. We simply need to refine the placeholder import and greet here. Specifically, we must undertake an initialization before firing up our greet function. Let's shift that index.html to our bucket. Bear in mind that it may be a few minutes before the cache releases this index.html. But, should you wish to bypass the waiting game, we could simply save this under a new file name. This is merely for our testing purposes, but voila, there we have it, our Hello demonstration alert is alive and sans errors. Now what else is on the plate? Let's proceed to setting up the networking for our website because we aspire to a website that stretches beyond the domain, performance, and scalability limitations of storage.googleapis.com. So let's voyage to the Google Cloud Load Balancing service where we shall create a fresh load balancer. A prerequisite here is unlocking the Compute Engine API if you haven't already done so in your project. Once we activate that API, we'll pivot back to our load balancers page in Network Services and create a brand new load balancer. We're looking for an application load balancer to handle HTTP like a champ. Our global external application load balancer should rise to the occasion. We'll select HTTPS, our gold standard when it comes to production-grade web protocols, and we'll redirect HTTP to HTTPS. The redirect will require a static IP address, so let's snag one right here. Next, we're going to need a certificate. Google's going to handle this for us so we can keep our focus sharp. Just input a domain you own, and it's in Google's capable hands. For our demo, we're going to roll with the notomatic.io domain. Alright, the load balancer front end's looking slick. Time for some backend action. We need to form a backend bucket where we already have our WASM files hosted. Also, let's engage Cloud CDN from this load balancer creation interface. Why? It lets us cache content at the edge and skyrockets performance. However, a word of warning. If we stick with the default cache static content, we get automatic caching for stuff like CSS, JavaScript, fonts, images, videos, and PDFs. But alas, we miss out on WebAssembly caching. An easy hack for enabling WebAssembly caching? Hit Force Cache All Content. Since we have no server-side rendering or other caching security issues here, we can brush off the warning. The more sophisticated alternative? Set cache control headers in our bucket and source object. A 1-hour TTL should be a good fit for our edge cache. Everything else looks shipshape, so let's get this backend rolling. Default routing should serve us well, pushing everything towards the single backend. Now that it's all looking 10 out of 10, let's tap that Create button. So we've tackled the stack, arranged our static files in cloud storage, and managed cloud load balancing and cloud CDN for top-tier edge serving of our WebAssembly site. Our users enjoy a rapidly delivered and infinitely scalable website. All that's left is the certificate provisioning for HTTPS. As soon as the IP provisions for the load balancer, we'll need an A record in our DNS system pointing our chosen domain to the load balancer. Let's snatch this IP and then in your DNS provider, wherever that's nestled, embed the A record for your domain. That crucial step isn't just key to serving our website on the domain, but it's also necessary for us to have our certificate automatically provisioned. The certificate in our hands is managed by none other than Google themselves, and they provision this certificate using an HTTP ACME challenge. Pointing our domain to this IP becomes non-negotiable for that process to run successfully. While our certificate is being provisioned, why don't we map out the all-important cost model? A couple of elements got our attention. To begin with, cloud storage. If we scrutinize our website and switch to the Network tab, we can assess roughly the total data we're dealing with. The heavy lifter here is this unassuming JavaScript file, chewing up about 3 kilobytes with an additional 2 kilobytes on top of that. So let's ballpark the site at around 5 kilobytes of data. Perhaps as expected, this is going to be incredibly inexpensive, and even better, if this is your sole usage of Google Cloud Storage, this falls into the free tier, leaving us with no cost at all for our standard storage. But we have another contender to take into account, the load balancing playing guard in front of our storage bucket. We've got one forwarding rule here, coupled with the global load balancer. Now let's imagine that this website rakes in about 20,000 hits each month. This means 20,000 times 5 kilobytes for outbound data, which boils down to 100 megabytes in total. Those inbound requests are going to be of an insignificant size as users aren't transmitting any data, so we factor that into our estimate. Our global load balancer carries a price tag of roughly $18.25. Plus, we have one IP address hitched to that load balancer. Eyeing Cloud CDN next, we'll make an assumption that the 100 megabytes of response data per month is approximately evenly distributed geographically. Don't forget to account for cache lookup requests. We've got 5 files in total and 20,000 requests per month, so that punches in at 100,000 lookup requests, costing us about 9 cents a month for our cloud CDN. The last card on the table is network egress. We're basing our assumption on an evenly distributed egress traffic across varied regions. This assumes we're ultimately hosting our bucket from US regions like US Central. Taking a tour through the costs grouped by service, we see that our cloud storage draws us a picture of zero cost. Our compute engine, a stand-in really for our static IP address, also costs nothing, and it's our networking that's driving all the costs. We're looking at total damage of under $20 each month for this high-octane setup. Why not now take a quick peek at our certificate? Since there's no refresh button on that page, we can navigate out and back in. Victory is ours. That certificate has been successfully provisioned. The moment of reckoning. We'll check out our website and go straight to the index.html, and voila, there's our hello demonstration. One very teeny tiny step from completion, getting our root directory to serve this website. Let's fire up our terminal here and run a gsutil command which tags our main page as index.html. We could also juggle with options like setting error pages if we've got them on hand. Brace yourselves, now let's check our root directory and voila, our website is serving flawlessly with cached content for our WebAssembly, JavaScript, and even our HTML. Everything is running on all cylinders, and we've been able to build a lightning-fast, global, internet-scale WebAssembly website without breaking the bank at less than $20 a month. Further, since the cost model is primarily driven by the load balancer forwarding rules, we could scale traffic dramatically beyond the modeled scenario without much increase in costs. We've included the demonstrated code and diagram for your reference in the video description. Thank you so much for tuning in, and please enjoy responsibly.